Good afternoon, everyone. So we'll start our next session, that is session 2 of our day 3, right? The speaker for this session is our own Professor Dayanand Ambawde, who is Associate Professor in Sardar Patel Institute of Technology, Electronics and Telecommunication Department. He is going to take hands-on session. Professor Ambawde is currently working as an associate professor in S.P.I.T. He is working as IEEE SB counselor and head of network infrastructure team of the institute. He has received MTech in communication engineering from IIT Bombay. He is having more than 20 years of teaching experience in areas computer networking, network security and management, and open source softwares. He has authored two books, Linux Lab and Advanced Computer Networks. He has published 25 plus technical papers in international conferences. He has trained 1500 plus students on Linux OS, server, network, and security administration. He has conducted hands-on workshops in the domain of networking and security using open source tools at various institutes and industry. He has successfully completed the funded project on security visualization of B.E.S.T. Government of India. He has received incentive award for excellence in teaching. He is the recipient of first Pradnavant 2006 award of Sw. Dadasaheb Udharkar Smarak Samiti, Karad, Maharashtra, conferred upon me by former Honorable Chief Justice of Supreme Court, Justice P.B. Sawant. He is member of IEEE, fellow of IETE, and life member of IST. And there are many more things to say about Professor Ambawade, but I guess sir should start now with his hands-on session. You will be get to know the expertise sir is having now. Sir, over to you.
Thank you, Sneha, for kind words. I hope I'm audible to you, Sneha.
Yeah, yes, sir. I will stop
Yeah.
sharing. You can start.
Okay. Thank you.
Yeah.
My voice is clear. There is no disturbance at all.
Yeah. Yes, sir.
Yeah.
Yes. Yes.
Thank you so much.
Yeah.
Hi
Sir,
to everyone.
I just want to inform participants that please wait for the instructions. Sir will give
Correct.
instructions. Yeah. Yes.
Correct. Should I give the instruction? Okay.
Yes, sir. You can start.
Yeah. Thank you. Thank you, Sneha. Hi to everyone. Dr. Amul Deshpande has shared files of Jupyter Notebook with you and the data set and few discussion about the data set what we are going to use. Today we are going to cover very basic laboratory wherein we are using Wisconsin breast cancer data set, which is available on University of California Irvine database. The same data set we are going to use it, and then we'll use machine learning techniques to detect the cancer, whether patient has a cancer or no cancer. So it's a classification problem. So I think since it's a first time we have been listening the seminars right from day one, and let's do some kind of hands-on. Sneha, how much time I have? I think 1 hour time.
Sir, till 1:15.
1:15. Okay. So we'll be
Yes,
able
sir.
to complete today's lab session.
Yes, sir.
Okay. Well, so let me share my screen with you. Give me a moment. Okay. Since it's a hands-on laboratory and we are using Google Colab, is my screen is visible to all of you? One of you just confirm it.
Yes, sir.
Yes, thank you. Sir, Professor Amol Deshpande must have shared with you.
Sir, आप उसको enlarge मत कीजिए sir. Sir, please do not enlarge it because it is not whole window is not visible if you are enlarging it.
Enlarging. Okay, not a problem. See, this lab you are supposed to practice with me. Okay, so don't worry about that. Okay, so already I shared mail with Dr. Deshpande. regarding the today's lab. So can you see the, I think, similar content, email content or attachment you must have seen in your, right? So let me first open it. So when you click it, you can just directly open it and you'll get an option. Okay, open it, sorry. So you select the Jupyter notebook file. I think it's second file in attachment. There are four attachments. Out of that second file is the Jupyter notebook file. Just open it. You'll get an option, open with the Google Colab. Select that, open with the Google Collaboratory. Okay, it will take you to the Google Colab. As you know, all of us are, because of this COVID-19 pandemic, all of us are depend on Google Colab computationally. So many of you are aware of what is Google Colab, right? So my screen is visible to you, and you can see the Google Colab window. Okay, and let me just briefly explain you this, what is the Google Colab, the section. So very first thing is, once you open this Google Collaboratory Jupyter Notebook, you just connect it, right? So connect to the Google Compute Engine. So connecting option towards your right side. I hope you are all following me. If in case any problem, you can type in the chat box. Okay. So,
sir, sorry
yes,
to interrupt. Maybe you can also
yes.
tell the option how to
Yeah.
get it from the disk, hard disk, if it is
Yeah. That is
available on the
also
hard
there.
disk.
Slightly.
Sir, how to open the Google Colab, sir?
Okay, let me repeat again. You go to the email attachment provided by Dr. Amol Deshpande. Select the second attachment, that is a Jupyter notebook file. Okay, and open it, and you'll get an option, open with the Google Colab. 1 minute. What I'll do is, once again I'll show you.
Sir, Amol sir has sent the.
Sir, I have given them and they have downloaded the
No, there's
files,
no
sir.
need to download this file since we are using online.
Sir, actually, I have shared through Drive and I have shared through WhatsApp.
Okay.
Sir,
So
it is available with WhatsApp, sir. It is available with WhatsApp.
Okay. So you can share. Just a minute. I'll 1 minute. I'll share with Amol again the same file, and then Amol share with you.
Sir, maybe you can tell how to upload it on Google Colab. The file
They
which
can
is
upload to their Google Drive. Hello. No. We'll follow one step by step. Okay. Since it's a hands-on, so you have to follow the step by step. So my suggestion to you is, I shared this file with you. Just share with them through mail.
okay, sir.
Sir, done? Amol sir? Give me the confirmation once you're done.
Sir, doing it. Actually, there are many extra email IDs also, so I was trying to avoid sharing it on email.
Directly my mail you can share with them. No? The mail I sent you, you can share with them.
सर आपल्याला अपलोड करायचं पण ऑप्शन आहे ना, असं मी म्हणत होतो.
No, no,
गुगल
not
कोलॅब ओपन
required.
करून.
Not required for uploading it. Okay, don't worry. I have found out some method where you can import directly that data set into the Google Colab.
Sir, drive
Okay,
permissions.
Sir, what you can do,
Ah.
simple way to do it, my mail, you just share, forward to all of them.
Sent, sir.
Okay, great. So I just will confirm with one of the participants. Okay. One of the participant will confirm with it. Okay. Digambar Puri. Yeah. One of the participants, let's have a common demo to all. Digambar, will you join as a volunteer? Digambar Puri.
Sir, people are responding in chat box.
Okay, fine. Okay, it's received. Okay, so then I'll just confirm with one of the participant. In that case, okay, so
Abhishek ji or Nilesh ji, maybe someone of you please confirm.
Abhishek or Vivek.
Yes sir, got it.
Yeah, got it. Thank you. So just to small demo to all of them. Will you just
Sure, sir.
volunteer? Yeah.
Yes, sir.
Just
Yes,
present
sir.
your screen. Present your screen. All of you, please follow the steps. Yeah. Abhishek. Well, so you just open your mail. So all of you, please follow the steps. Open the mail, and
Is it seen, sir?
no, it was stopped.
Yes,
It is there,
your
but
screen is visible. Yes.
share the new
Sir,
tab. I think. Yeah,
is it?
correct. Yes,
Okay,
now
okay, sir.
it is open. So you
Okay,
open
okay.
that mail.
Okay, sir.
Second step, you go to the attachment.
Okay.
And
Sir,
then
is it
second
seen?
file. Second file.
Session
Second
1.
file. Yeah, session 1.
Okay, okay, sir.
And it is asking you open with. Can you see the option on top? Open with on top.
Yes, sir. Yes, sir.
Open with. Click that open with.
Yes,
Drop
sir.
down menu. No, stop this. Sorry. And open with Google Colab.
सर ओपन विथ मध्ये गुगल कोलॅब दाखवत नाहीये त्यांच्या ह्याच्यात.
Okay.
आय थिंक आयशा मॅडम मेसेज टाकला की द वन हु हॅज नॉट युज्ड मे नॉट गेट दॅट ऑप्शन.
Okay. So for them, what you can do, go to Google search engine and just type Google Colab.
Okay, sure, sir.
सर म्हणूनच मी ते अपलोडचं ऑप्शन म्हणत होतो.
Okay, not a problem. What I'll do
ते
is,
सोपं केलं.
don't worry. I'll start from basics. Okay, don't worry. Hello.
Yeah,
Yes,
sir.
sir.
Google Colab. Google Colab.
Yeah. I can start from Google Colab rather than opening that file. So give me a moment. Okay, give me a moment. So all of you, you have this file with you. Don't worry about that. So let me start with a Google Colab. So
Sir, shall we open it in the new window?
Yes,
New tab.
open in a, just a minute. I have changed my method. Wait for a minute.
Sir, we got that Python
Jupyter
collaborator.
notebook file.
Yes, yes,
Yes,
yes.
yes. Google Colab.
Yes, sir.
Okay, second method. Let's just follow. Supposedly, I'm working on Google Colab first time. How to do it? I hope my screen is visible to you.
Yes, sir. Yes, sir.
Yes.
Yes, sir.
Absolutely.
Yes, sir.
Yeah. So
This
just
will be better, sir.
search for a Google Colab. Okay. And
Okay, sir.
select the Google Colab. And then you can select. Now I think it is available to, if it is uploaded on Drive, it is available to you. Otherwise, forget that. And select the option at the bottom, new notebook towards your left.
New notebook. Yes, sir. I have got it, sir. Okay, sir.
Got it?
But some error is there, sir. Yes, sir.
Are you following me or are you following the earlier method?
No, sir. We are following you, sir.
Yes, yes. So you'll get a Google Colab Jupyter Notebook window.
Yeah, sir. Yeah.
Yeah, thank you. So after having done this, very first thing is you go to on top and rename that file. Suppose this is my lab 1, laboratory 1, okay, and ML approach to machine learning. Sorry, ML approach for your medical diagnosis. That's the name of my file. Okay, and then go to your right and connect it. So you get a message connecting, initializing. So you'll get a Google Compute Engine and just hold the cursor over there and you get additional information.
Sir, 1 minute, sir. Sir, 1 minute. Lab. And
Connected. It is showing connected, sir.
Connected, right? And you can check your Google Compute Engine. It's a Python 3 Google Compute Engine with a RAM around 16 GB and disk. Okay, that's it. That means your your platform is ready. Now understand the basic of Google Colab. You can see over here, there's a code segment, okay, and there's a text. So you can write a remark like we used to write a remark in C language, now. So similarly, you can use the markdown concept here. The text. So you can add a text. Suppose I want to add a text. Okay, so you can add it over here. Let's say to detect breast cancer. Okay, that's my objective of today's lab. Okay, so and code segment you can add a code, right? Fine. Up to this is clear. Up to this point is clear.
yes, sir.
Okay.
Yes, sir. Yes, sir.
So very first thing is you have to import the libraries. You have to understand the data science framework or ecosystem of Python, which is very widely used, which is I mentioned in my Google Colab Jupyter Notebook. So you have to import the pandas, which is a data frame library. Pandas as a PD, short name, aliasing. Okay. Then import NumPy, because Panda is built on top of a NumPy, so NP. Then if you import the SciPy, scientific Python as SP, then import the matplotlib. Matplotlib is a graphical library in order to plot your histogram, bar plot, scatter plot, and so on. We require a library, and that is a matplotlib library. You can even import one more library, Seaborn, as a SNS. So SNS is a short name of it, right? So you don't have to call by entire name of that library. Next is in order to display the plot, you can use Matplotlib inline magic. Okay. Up to this point is clear to everyone?
Wait, sir. Wait.
Yeah.
Sir, how to include? Sir, how to include the library, sir?
How to
include the library?
Import the library. I said importing the library.
Sir.
Yeah.
Yes, sir. How to import it?
You can see here the command import pandas as PD. Yeah. So we are
Sir, it is
calling
not
pandas
easy.
as DD.
Sir, sir, please reduce the screen, sir. Do not enlarge it because it is not completely visible.
1 minute. That option is I don't have.
No, sir. Actually, screen is completely visible.
Okay,
It's
no,
a
now it
completely
is
visible.
visible, sir. Yeah,
Yeah, yeah.
yeah, it
Okay,
is
thank
visible.
you. Thank you.
No, sir.
So next step is, yeah.
सर प्लीज
Ambawde,
इसको
sir.
छोटा कर सर इसको
Ambawde,
छोटा
sir.
कीजिए सर
Yes,
सर
tell
जरा
me.
छोटा करा थोडं छोटा करा सर
सर
दिसत
इथून
नाही
ते
आहे
डिस्क वरची फाईल आपण अपलोड करू शकतो ना, जे सेव्ह आहे हार्ड डिस्क वर. म्हणजे
हा,
तुम्हाला हे
that
टाईप
is,
पण करायची गरज नाही परत.
yes, yes, yes.
यू कॅन, म्हणजे ते पण तुम्ही दाखवू शकता अपलोड करून.
Okay, fine, fine.
हा, फाइल्स.
Okay, so that's
तुम्ही,
the same thing, no?
हा
Okay.
हा,
So,
ओके सर.
so I'll go back to, okay. So in order to, speed up the process, let me once again go back to earlier step only. Sorry for that. Okay, so open your second file. Open in a Google Collaboratory. Okay, so this is the data science and machine learning framework or ecosystem wherein we are using pandas for data frame analysis, NumPy, numerical computation, your matrix computation, scientific Python, that is SciPy, Matplotlib, Seaborn, and your Jupyter notebook. The very first thing is you go and I think this is visible to all of you, right? Now run this, import this library, pandas, NumPy, SciPy, Matplotlib, Seaborn. Okay, after having imported, the next step is you are going to load the data set as a pandas data frame. So wherein you are going to use pandas read.csv function to read the data set which is in comma separated value and create a data frame. So this is just the basics of pandas data frame, where you can see the rows and columns. So rows are nothing but your records, number of records, and the columns are nothing but your features, right? So this is a data frame structure. So in order to, you can see this data set is available on Wisconsin breast cancer data set on a UCI website. So link is given to you. Just copy this link. So next step is to copy this link, okay, as a URL. Okay, let me check. Copy this link as a URL. Don't have to upload this, right? So you are as copy as a URL, and then you can proceed with this directly URL, right? So you are importing this data set directly from the UCI website, okay, and you are loading it. So this step is to load the data set and create a data frame in a pandas. Okay, and run it. So yeah, column name is not given. So this data set is, there are no column names. So what you are supposed to do, the column names are given over here. So you can go to the next step, a column name. So it's a list is provided to you. So first you run this list, column name, and again you go back to the loading the data set. Okay, so there is no error. That means data set is loaded, right? So next step is, let's verify this data set. So you can add a new code. Okay, so let's say, let me see the first, review the data set. View the data set. Okay, so just type df.shape. So it gives you the data set which consists of 699 records, observations, and 11 variables. Okay. Next step is even you can check the what is a let's say the first 5 observations. You can see this data set consists of the sample ID, the these are the variables, clump thickness, right? and so on. So all these are column names. So by default, there is no column name. So we are supposed to give the column name. So that step we have done it. Next step is to just find out the what are the observations over here. So you can see here the sample ID, cluster thickness, clump thickness, uniformity of cell size, shape, adhesion, and so on. And you can see the last column, which is a diagnosis. So it's a labeled data set. So it's a typical case of a supervised machine learning. So before we go to the supervised machine learning model, let's first explore this data set. Okay. So yeah. So one more thing is I need to understand here is let's say df.tell cell side 5 observation from tell and the head side. So total are 6. So numbering start from 0. Remember the index number and your last is 698. So total 699 observations. Okay. One more thing we need to find out. Sorry, your is the df dot columns. Okay, df dot columns. Whether the columns are so all the columns are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So 11 columns properly renamed with the list. Next step is, it's very important, is data handling, what we call data processing. So this is also data set may have some kind of missing data. So in order to find out that missing data, you can actually take the data D types, and you will come to know your these data types all are integer, right? Data types, numerical data types. Okay, well, fine. So next step is you can do some basic statistical summary. So how to do that? So df.describe is a function to describe it, right? So but then ID is anyway, it's a sample ID number. Just focus on the clump thickness. So there are total 699 observations, and mean value is 4.41. Okay, standard deviation 2.8, and minimum value is 1, and maximum is 10. So you can see the range is values between the 1 to 10. And the first quarter, first 25%, then next 25%, that is up to 50, and the third quarter up to 75%. So you know the interquartile range, okay, which is 1.5 times of IQR. Okay, so it's a first quarter, the third quarter minus the first quarter into 1.5 times. Either of the side is going to give you outlier in this case. Okay, so you can see here describe command to okay. So one more thing I have not mentioned here, please follow it. I want to do the quick EDA. So there's a concept of quick EDA. Okay, wherein we are going to use pandas profiling. So from pandas underscore profiling, import, or you can import let's say star, and then you can pass this frame, okay, to profile report. So you can, it's a profile report is a part of your pandas data frame. So pass this entire data frame to the one minute, sorry. Give me a moment, okay. Hello. Yeah, I hope up to this point is clear to everyone how to load the data set from the UCI website and rename the columns and describe the data set. Okay, so entire ML steps are given to you step by step, so you can make use of them. Okay, next step is, okay, I'll just, let's first find the variation in the mean. Okay, so you can df dot describe. This is we have done it. Okay, so what you can do is df dot describe, and you are interested in just find the mean. Okay, so mean of it. You get all these means. So this you can actually plot it. So you can do the chaining of method. You can plot find bar. Okay, all these instructions are given on top. Sorry, on above this instruction. Just follow it. Figure size. Hello, any difficulty? Please let me know. Yeah, certain issue with this. Okay, so what we can do is let me check. Anybody has got a plot here? The mean plot of various variables. Okay, let me check this. There's some error. So let me first display the. Am I audible? Hello.
Yes, sir.
Yes, sir. Yes,
Yes,
sir.
sir. So there is some. So you can check it here. Okay. This entire frame. So it is showing only this. Okay. So what we can do is, but then I can check even cell side. All these values are there or not. Okay. Let me check one more thing. Is there is a possibility there could be a reason. I need to check with the df is there is null value in any of the variables, and then sum of it and just find out. Yeah, there are 6. Yeah. I got the problem. See, this data is also some missing values. Okay, so what you're supposed to do is, very first thing is you figure out is there any null value there. Okay, so you can, that null value you can fill with a 0 at this point, because 16 out of 699 is around 0.02, means 2% approximately. So it's not going to make a difference. So for simplicity, we'll avoid data imputation. Okay, we'll just fill with a NA. Okay, fill NA with a 0. Any value with respect to this, it will fill with an NA value. Yeah, and then once again rerun it and confirm it whether it's now 0. Okay, and go back and try to plot it. Okay. Okay, I think this version with a problem with, let me check with the OS version. And then we need to reinstall the pandas profiling. Okay, I know this. This is a problem with respect to this particular Google Compute Engine. So we need to reinstall the pandas profiling, but we'll not do that because of we have very less time to complete this lab. Okay, up to this point is clear. Okay. So
Yes.
now,
Yes, sir.
right, yeah. Now, if you look at the data set, this data set consists of 699 observations and 11 variables, out of which last one is a diagnosis, which is your label. Well, so, and you can check it out, this column, this diagnosis. Last one is a diagnosis. And then ID is not going to much make a difference. So what we will do is, we'll convert this into features and the response variable. As you know, machine learning, what is in machine learning? We pass the features, X is a feature and Y is the outcome, that is response variable, to the ML model. Okay, ML model, machine learning model, and model, what it does, it estimates the function. So what it does, it estimates the function. So what's the machine learning in simple words? Is nothing but Y is a function of the X. Okay, where X is a feature vector and Y is a response variable. So for given X and Y, the ML model estimates the function. Okay, and so that's exactly what we're going to do it here now. So see, X is a feature vector. So we will, from the data frame, we will drop the some of the features which are the ID is not required. Okay, not so important here. So we will drop the ID, and you can pass that ID and the diagnosis, which is a label. So we'll pass ID and the diagnosis and create a X. Let me run it. And axis 1 means column axis equal to 1. So this is my feature. X is feature, and Y is your response variable. That is your data frame, and the last variable diagnosis. So you can pass it diagnosis. Yeah. After having done this, that means I partition the data into the feature vector and the response variable. Okay. So before we go to the next part, let me see the first distribution of the data frame, the group by function. We can use group by function to understand this diagnosis, okay, by diagnosis itself, and count it and count. And you'll get to know there are 458 are benign tumor, that means no cancer, and there are 241 cases are the malicious, okay, that is malignant cancer. Okay, so this data set consists of total 699 records, out of which 458 are benign, which is not cancer, and 241 cases are having a cancer. Okay. Next step is you have to split this data set. To, before you build a model, next step is to build a model. To build a model, we need to split the data. Split the data into train and test. Okay, so train 80% training data. We are randomly going to choose from this data set as a training, and the holdout data, that is test data, is around 20%. That's a 20%. Okay, that's the thumb rule. You can take 75, 25, that's also fine. Or somebody can take 70, 30, that's fine. In order to have a common outcome, that means your accuracy, precision, recall, F1 measure, let's keep it 80, 20%. So this step is you are going to split the data into 80%, and for that we are going to use the scikit-learn library, sklearn, and it has a model selection as a sub library, and from that you can import the train split, train and test split. Okay, and it will result into two tuples. So what we are doing is we are dividing the data set feature vectors into train, and what is corresponding is we are dividing two features into train and test. Okay, and corresponding the Y train, that is a label, and corresponding Y test for validation purpose. So train underscore split, this function takes two inputs, it takes a feature vector and the response variable, that is Y, and let's say test size. This time I want test size is let's say 0.2, that is 20%, that means your training size is 80%. And in order to have a repeated results, you can use random state equal to, let's say 1, 2. Okay, anything you can take, number. Okay, and we are splitting this data set into train and test. Yeah. After having done this step, next step is you just check the size, xtrain dot shape. You can print this, print xtrain, and you can print even xtest. So we are splitting this data into xtrain and x. Okay, and then we're going to verify the dimension of it, and you'll get 559 and 9 variables. ID we have dropped it. Diagnosis is a response variable. So feature vectors are 9 variables, 559 and 140 tests. So you can find out total number of the records. So it's a 699. Okay. Next step is you can check even within the text size, within a Y test. Okay, so even you can check the Y train and Y test. They should be of same dimension, the X train and Y train. So let me check, verify it before we go to the build a model. Okay, that's a 559. and even you can check your Y test shape is. So let's go on. Next part is let's now build a model. ML model. Okay, so since your outcome is a categorical variable, whether patient having a cancer or not a cancer, so it's a categorical case. So we are going to use a classifier, it's a classification. In machine learning, we have two problems: regression problem, where we forecast the value. Let's say the cost of a flat, which depends on the area of the flat or the configuration 1 BHK, 2 BHK, the amenities and the age of building, wherein we able to forecast the value. So that thereby we use a regression. Here, based on example, let's say it depends on whether the person is highly qualified, what is his designation, what is the age, the family. Based on that, whether he will buy insurance or not. So it's a typical case of a classification. So in machine learning, there are two problems: regression and classification. As per our data set, so there is whether patient is diagnosed as a not a cancer patient or having a cancer disease. So it's a classification. So it's a classification problem. Okay. So we're going to use supervised machine learning model. Let's say the very first model we'll use it is let's say decision tree. So from scikit-learn, or you can use even simple logistic regression. So by sklearn, you can import library. It's a linear, because linear regression is a foundation to the machine learning, wherein we are going to use now logistic regression, since it's a categorical variable, your logistic regression, right? And then we're going to train the model. So first part is to train the model, and next is the predict. Okay, and third thing is we're going to find out the score, accuracy of it. Okay, so one by one. So train the model. How to train the model? So what you can do, you can use let's say I'm going to use the object name as a CLF. We are going to create an instance as a classifier. Let's say this is my first classifier, or I can give appropriate name. Decision tree, the logistic regression. Okay, and I'm going to import the function. So it's a function. So it's create an instance. Okay, and then we want to train this model using CLF underscore log fit. Fit is a function. So all these information already I mentioned in my Google Jupyter notebook. You can just follow it. So fit, and to fit the model, we use xtrain data, the Y-train, the corresponding label Y-train. And to predict, so what I'll do is, even we are interested to know, we are supposed to find out various evaluation metrics like accuracy, misclassification rate, precision, recall, F1 measure, Cohen's kappa value, and even ROC curve, receiver operating characteristics. Okay, so and we are interested even know what is the prediction time and the training time. So we'll do that little later. Let's keep it as simple as possible, and then we're going to predict it. So I'm going to predict. So once model is ready, it's going to predict. Okay, so we'll use the predict function. So CLF is the name of the model. Okay, and the predict is a function, and predict we're going to predict is a function. So you'll pass the X test, which is your pulled out data, validated data, and it will predict the value, Y prediction. Okay, and then finally you can use a score directly, CLF log and the score, and to which you can pass the X test, and the Y test is the truth. And then we'll elaborate further on this. Okay, do this? Okay. So let me first, very first model is a logistic regression, and I got accuracy score is 97.85%. Okay. So let me explain it step by step. So this is a classification problem. So for which we are going to use the logistic regression, very first machine learning model, and then we imported logistic regression from the scikit-learn library. So there are three functions you need to remember. One is the fit, predict, and the score. So fit is function to train the model based on your training data, and the predict is a function to predict. Okay, and then score is to find out the score. That means 1 minus this is going to give me the misclassification rate. But whether my model is learned well or not, how do I find out? We can use a confusion matrix. So what I'm suggesting you, you just follow my write-up, this, and evaluate the model, create a confusion matrix for which you are supposed to call the scikit-learn matrix. Okay, and use a confusion matrix to understand how our model has worked. Okay, and then use various other models like neighbor-based model, k-nearest neighbor, decision tree, random forest, etc. And based on various evaluation metrics like accuracy, misclassification rate, precision, recall, F1 measure, ROC curve, which is the receiving operating characteristics, AUC, which is area under the curve. You find out for all these models, right? And also you find out prediction time and then the training time. And based on this table, we can able to select the best model for this particular data set. Okay, so this is a hands-on laboratory. I showed you very basic lab to you. Now you can take over and find out. So you can create now groups and follow this write-up, use other models and compare the results. So Amol Deshpande sir? Amol?
हाँ sir, बोला.
Yeah, so can we create now groups and so that they can be part of that group? So let's say group of 10 people, we can use that facility over here. And
We can use that, but there might be a little bit of jumbling, thoda sa.
Is it?
I feel that personally.
As well. Okay, fine. So then what I'll do, I'll complete this one, but demo lab only, and then we'll give you the exercise to them, and they're supposed to submit it, right?
Yes, sir. And maybe we can take up questions if they have.
Yeah. So let me finish that, how to create a confusion matrix, and the all these the evaluation metrics, and then comparing it, right? So let me finish that, and then we have a question and answer session.
Yes, sir. Yes.
Okay. Okay. So let me go back to the lab. Okay. So we have just used one model, but there is still scope for improvisation of this model. But let me see first how this model has worked. Okay. So what you can do is we can use from scikit-learn, sklearn, import metrics. Import metrics is a function. Okay. The library of learn, and from this we can create a confusion matrix. So you can write metrics and the confusion. Okay, let me run this first and then it will work. Okay, and then metrics confusion matrix. You can see confusion matrix, and to which you pass the truth, which is a white test, which is your hold out label, and the Y prediction, which is predicted one. And it will create a confusion matrix. Is it visible to all of you? Confusion matrix. Yeah. So you can see the diagonal.
Yes, sir.
Yeah. confusion matrix, you can see the diagonal is the correct detection, and the off diagonals are misclassification. So if you total misclassification are 3, 1 plus 2, 3, 3 divided by 619, sorry, with respect to test data set, right? So it's a 140. So, okay, 1 minute. Just let me check. The 87 plus 50. And then 137, yeah, 140, correct. So it's a 140, the total X test, okay, and the Y test record. So out of 140, we are 137 times correct, 140 times is correct. That's your accuracy. And 1 minus this is going to give you the base classification. Yeah, this is about confusion matrix. Similarly, you can generate entire classification report, because you are supposed to find the accuracy, misclassification rate, misclassification, precision, recall, F1 measure, AUC, area under the curve, and the receiver operating characteristics, and the training time for each model, training time, and prediction time. Those many parameters you are supposed to find out for each model: accuracy, misclassification, precision, recall, F1 measure, and the prediction time, training time, area under the curve, and all that. Okay, so you got accuracy 97.85%, 2.14% is misclassification. Now you can find out the precision and the recall. So how to find out the precision and recall? So we have a matrix, is a library of scikit-learn, and then classification report. So you can see the classification report, to which you're going to pass the truth, which is your Y test and the Y prediction. Okay, sorry. So let me print this. We'll get to know the precision, recall, and F1 measure. Okay, next part is, let me even find out the what I said. Precision, recall is done. Okay, accuracy is done. This class is done. The F1 measure done. Now we have to find out the receiver operating characteristics, right? So for which we have to call the there is a function. Okay, 1 minute. Let me try. Matrix dot plot. Yeah, plot ROC curve, and to which you have to follow. We can check ROC curve. You're supposed to find out. You can use a question mark to find out the help about how to find out the ROC curve. Okay, so you are going to provide the model, which is your classifier, the X test, which is your hold out data, and the label Y test. Okay. So for ROC curve, the model is your this, then X test, and followed by the Y test, the Y prediction. So X test we are finding, and then the features, and then X test. Okay, so that means it is computing the Y prediction on the fly and calculating it and finding the curve. Yeah, you can see the curve here. The ROC curve, which is the receiver operating characteristics, nothing but false positive rate versus true positive rate, and AUC value is 1.1. Okay, that is area under the curve. Okay, so anything is above this, if you plot, let's say 0, 0 is the origin, and let's say true positive is 100, 1, and this is also 100, means 1. And if you draw this line, it creates a 45 angle. Okay, anything above this is considered to be a good. So in our case, we are getting 97% the accuracy, which is considered to be one of the good model. Okay, but what is about the model complexity? I mean, how much time it takes for training and how much time it takes for testing. So let me check it out that as well. Okay, so what we'll do is, let me go to the down and let me take another classifier. Let me take another classifier and let's verify the training time and testing time. Okay, so let's say from scikit-learn, we will take this time the, let's say, k neighbors, knn, the k neighbor, nearest neighbor, okay, as a classifier. We'll put knn neighbor import k neighbors classifier, okay, and CLF2, I'll say CLF2. This is my classifier. Okay, let me run this because it takes time in. Okay, so CLF2 a nearest neighbor classifier as instance and use it to this model. Okay, so let me check now metrics with respect to this model. It's on the fly does it. So why metrics dot classification report, otherwise the ROC curve plot ROC curve first, and then we'll go back. Okay, so LF2 X test and the Y test. Okay, that means model needs to be fit first. Okay, it doesn't take it that way. So it doesn't do all on the fly. I'm sorry. So we'll have to do CLF dot the second model as a KNN model fit X trace and Y trace. Okay, here we will find out the prediction time and the training time. So you can import time as time dot time, or you can also write percentage time. Hopefully it will work. Okay, and let me find out the prediction time. No, it's not here. Okay, so what you can do, you can import time function, and then starting time is equal to time dot time, this instance, and the ending time, end time is equal to after fitting it. Okay, time dot time and print minus the start time. So you'll get this type. So since record only 699, so you'll get hardly few seconds to not even few seconds. Okay. So this way you can find out. Similarly, you can find this is your prediction time. So you can write over here. This is your prediction time. Prediction time. Sorry, training time. See your training time. Similarly, you can find out the prediction time. Just copy this function here, and instead of here a y prediction, so y prediction 2 for second model. So PLF2 is the name of the model, and predict function X test. We predict device. So there is some time in prediction. If you look at the training time is less as compared to the prediction time. So you can find the prediction time, training time, accuracy. So all these parameters we are supposed to find out for various other models, and then compare these models and find the best model. That's it, a task for us today's lab. And you can form the group. Group is not possible, sir, right? Amol, sir? Amol, sir?
सर ऍक्च्युअली आहे पॉसिबल पण थोडंसं जम्बलिंग होऊ शकतं.
Okay, not a problem. See, this is extract for them, homework.
Correct.
Yeah. So now I have used two models. One is K nearest neighbor and the logistic regression. Now they are supposed to use other models like neighbor-based models, decision tree, random forest, okay, and so on, and at least 3 to 4 models, and compare the accuracy, misclassification, precision, recall, F1 measure, ROC, and AUC, and then conclude. Is that fine? And they can use the same data set, or there's one more data set I think I shared with you, which is a cardiotopography, which is related to the abnormality in a pregnancy. Have I shared with you, Amol?
Yes, sir.
Yeah.
Should we take up some questions?
Yeah, you can take it now. Question. Thank you.
Thank you, sir. Just let me check the question answer.
Thank you so much, sir. Ambawde, sir, there is one question about concept of confusion matrix.
Yes.
So if you can tell us in a short.
Yeah. Okay. So confusion matrix is one of the major to verify the performance of the model. Supposedly patient is having cancer and is not been detected. That means it's a false negative case. It's a type 2 error. Okay. Patient is no cancer, but it's been detected as a cancer. It's a false positive. It's a type 1 error. So within that, we're going to find out how many true positive in the sense the patient is having a cancer and its system has detected it is a cancer. It's a true positive case. right? If patient is no cancer and detected as a cancer, it's a false positive. And patient has a cancer and is not detected as a cancer, it's a false negative. And patient doesn't have a cancer and system also says there's no cancer, it's a true negative cases. So you can see this. Okay, let me go back to my presentation. The Google notebook it's already explained. Okay, is it visible to you? The confusion matrix. Yeah.
Yes, sir.
So confusion matrix is visible to you, right? So it's a true positive. That means your predicted is also saying there's a cancer, and your actual is also cancer. It's a true positive case. If there's no cancer and not predicted a cancer, and actually also no cancer, it's a true negative. That's why I said the principal diagonal is your correct detection, and the off diagonal is the misclassification. So misclassification can be of two types. False positive means patient is all right, but is detected as a cancer, which is a false positive case. Or patient is having a cancer which is not detected as a cancer, is a false negative case. This is the concept of the confusion matrix. So all these parameters, the precision, recall, the F1 measure, all these are calculated based on this confusion matrix. So supposedly if I want to calculate accuracy, what is accuracy? I just now calculated the 87 plus some other number. That means I was summing up this principal diagonal divided by total. That means true positive, false positive, false positive, the false negative, false positive, and true negative. That's accuracy. Correct? Similarly, so once you create a confusion matrix, from that you can find out accuracy, precision, recall, F1 measure. F1 measure is a 2 times precision into recall divided by precision plus recall. Okay. So that's the concept of, I hope I answered this question. Any other questions?
Yeah, sir, there is one request. If you can show how to load the data.
How to load the data. Okay.
Yeah.
Well, so let me go back to my first step. How to load the data. So there are many ways one can load the data. Let me show you what we use today. So already we are aware of the data set related to breast cancer is available on UCI website, which is University of California, Irvine. And most of the researchers use this website for downloading the data set. I can actually directly import that data set from the same website. How to do that? Okay, you can see here the steps. So we have to mention the source. So I define as a variable URL, and you need to know for that data set is available over there. You can doubly ensure it is there, right? And then you right click that data set and copy that link and paste it over here. Clear? This is one way. Second method is, Second method is, can you see my towards your left side, there is a symbol like a cabinet. Okay, just click it over here, and you can actually upload your data set from your disk, from your computer. So you can click over here, and let's suppose you have some data set with you. Let's say I have a data set with respect to 1 minute. I'll show you a demo of that. So you can go to home. Okay. 1 minute. Yeah, and you can go to your computer, find out where is your data set is, and then you select it. Okay. So supposedly I have a cardiotocography data set with me, or any other PIMA Indian data set with me. Let's say I'm select a PIMA Indian. I hope this is not visible to you, but moment I upload it, you will get to know. And I'll say okay. So now this data set is uploaded over here, right? So you have to use this method to upload a data set from your disk. And then what you can do, go to you can see 3 dots here. Right click the 3 dots and copy the path. Okay. So, and then you can read that data set into your data stream using pandas. Is it clear? I hope it's clear to you. Thank
Yes,
you.
sir.
Thank you. Thank
Yeah.
you. So there are various methods. I explored two. One is directly from the website. If you know the URL, the source, you can select the dataset, right click, copy the link, and define the variable in your Jupyter notebook in Python environment, and you can make a data frame out of it. That depends again size. This case size was small, that's why it could take a fraction of a second to load it. But some cases, sometimes some data sets are in GBs. It will take a whole lot of time. So second method is you can download a data set to your computer and go to the process I explained to you and upload it from your computer to your Google notebook, Colab notebook. Third method is you can even load the data from your Google Drive, but it requires certain permissions. So it's a little bit cumbersome, because you need to it will ask for your permission. It will generate a code, one-time password kind of thing, and then you have to enter it over here, and then you can even access your Google Drive. There is another method that you can even mount your Google Drive, again with permission, into your Google Colab. Yeah. Aisha has a question. So question being asked by Aisha is, Google has two products that let you use GPU in the cloud for free, Colab and Kaggle. Can you highlight when to use for the AI and deep learning application? Yeah. So you can use GPU, it's a free, I know. If your data set is too big, so obviously you'll be using some kind of deep learning methods wherein you can use GPU, and it's free. So let me show you demonstration how to do that. Shall I show you demo, Aisha? Yeah. So
Yes, sir.
Yes, sir. So you can go back to your the Google Colab, and you can see the runtime. Okay, and then select change the runtime type. Once again, I'll repeat. Go to runtime menu and select the change run type, and here you can select the GPU and even tensor processing unit also. There are two options available to you, GPU and the CPU. Yeah, and save it. And need to restart the runtime again so that you can make use of the GPUs. Have I answered your question, Aisha? How to select a GPU in a Google Colab?
Yes, sir. But sir, there is another product called as Kaggle also. So like
Kaggle, yeah. Now Kaggle is a sub part of now Google, I believe. Am I right? Somebody can correct me if I'm wrong. Now, if you have a Kaggle account, you can make use of a Kaggle notebook. And Kaggle also provides you the GPU.
yes, sir.
Yeah. One more thing is, I think NVIDIA Academy, they also provide you the GPU if you have an NVIDIA account with you. Fourth source is you can use a Microsoft Azure. If you have Microsoft Azure cloud account with you, I think Microsoft Azure also provide you same kind of infrastructure to you. Yeah, thank you. Yeah. Any other questions?
Participants, are there any other questions?
As far as GPUs are concerned, you can use Google, you can use Kaggle, you can use NVIDIA, and then Microsoft Azure.
Sir, I don't think there are further questions.
Yeah, thank you so much.
Yeah, thank you, sir. Sir, will you please stop sharing?
Yeah, thank you.
Yeah.
Exercise for them is homework is they are supposed to work on other classifiers and find out these parameters, evaluation metrics, right from accuracy to AUC, and submit it. Thank you.
Okay. Thank you so much, Ambawde sir, for this whole hands-on session, and you have given minute details from how to load the data, how to take out confusion matrix, various methods to load the data, and everything. So I hope this is beneficial for our participants. So thank you so much. And sir, kindly accept this virtual memento as token of gratitude from us. So once this pandemic is over and we'll all gather in the college, we will give it to you personally.
Yeah,
Thank
thank
you
you.
so much, sir.
Thank you so much. Yeah, bye.
Yeah.
Thank you, sir. We can have a break.
Participants,
Yes.
yeah, participants, you can have a lunch break. Our next session will start at 2. That is by Dr. Samyak Mulkutkar from Hinduja Hospital. So try to join like just